start over here. So we're going to talk about the area of a triangle, but it goes much beyond area equaling 1/2 base times height. Now, it definitely starts there, and what you guys will find out is that we're going to create, I think, like 3 sets of formulas that all stem back to 1/2 base times height. But the interesting thing is that we can find the area without just having the base and the height. That's what I wanted to say too. We can find the area without just having the base times the height. But it all goes back to 1/2 base times height. So again, you're going to walk out of here with some formulas. Make sure that they're kind of highlighted in your notes. Maybe you'll put a box around them or something. Of course, this is our first one. And don't forget that that is simply saying that any triangle is just half of a rectangle. At least the area of a triangle is really just half of the area of a rectangle. Some fundamental ideas from geometry. So let's take a basic triangle that has a base and a height, which obviously is a right triangle. And I want to start to edit it a little bit. I want to say to you, and you almost have to kind of just watch this because I don't have like a cool digital animation, but if you take point A, if you take angle A and you drag it over here, so if I take A and I drag it over, okay, well, that's some things are going to change. One of the things that's going to change is now side C is no longer the height. Interestingly, though, there still is a height, but we'll kind of dash it up so that it's not confused with part of the triangle. So now I kind of slid angle A over, and what can we do? Well, what you're going to see is that we have a side angle side. Sometimes students aren't sure like what we have now. I just want to make sure you realize that I still have these 3 dimensions. I still have those 3 dimensions. It's a side angle side. I can actually use those dimensions to help describe the height using part of this triangle. Now you're going to feel like you've done this before, I hope, but let's do it again. Let's talk about the height of this triangle and its relationship to angle A and side C. The way that I would have worded this a week or so ago is I would have said, can you make a relationship between HC and A? Can you make a relationship between HC and A? I think I hear something. No, it's not the guys out in the hall. It's what relationship exists between these 3 variables? Good. Even said with a little bit of enthusiasm, the sine of A is equal to H over C. Now, if you're like, so why are we doing this? Well, because we can say the height is C sine A. I hope that you kind of have that B sine A ringing in your ears, B sine A. But it doesn't always have to be B sine A. It could be, in this case, C sine A. And what ends up happening is that this height right here, this C sine A, is able to replace the height in our formula because, of course, that's what it's equal to. And we end up with a new variation. We end up with a new variation. Let me help you to kind of get your notes organized before we write it down, because this is going to be the variation for side angle side. But now for the fun part, which is taking C sine A and putting it, substituting it, replacing it here for H. And look what you get. You get 1/2 B C sine A. You get 1/2 B C sine A. It actually has a little ring to it. It's 1/2 BC sine A. Now that's how you can find the area if you have side angle side. And specifically if you have BC as your sides and your angle is A. But again, that would be a nice little side angle side. As we did with some other formulas recently, you can take this and you can change the letters based on what you would be given. And so you could do AC sine B. That would be, of course, if your side angle side involves those three dimensions. And maybe you just want to take 10 seconds and think about the other variation. It's the only one that we haven't seen. It would be AB sine C. Of course, 1/2 AB sine C. Okay, now that's the formula that most looks like, that most feels like our original formula. And remember what happened? We just replaced the height, again, in this case, with C sine A. Why don't you try it? You'll find that today's lesson is not the hardest lesson all year, but still try to find the area if I give you some dimensions. What will end up happening with this lesson is we will be able to now stick area into our conversation. And that'll be coming next week. For now, just see if you can find the area. It makes for a nice little Thursday morning activity. Side A is 7.5. Side B is 9. Angle C is 100. And you should be getting a little bit more than 33. A little bit more than 33. How did you set yours up, Camry?
I said area equals 1/2 times 7.5 times 9 times 150.
That's all there is to it. Again, pretty easy. Now, I will say that when all this starts to get blended together with even what you just did on your test, that is just talking about dimensions of a triangle, stuff that sometimes kids start to do is they take this side angle side and they kind of confuse it with the law of sines, the law of cosines. The law of cosines. The law of cosines was for side angle side, but that was for finding the dimensions of a triangle. And this is for area, so it's a little different animal. I like to label it. I'm not like sort of the label Nazi, but it is units squared. Realize that you now found the space of that triangle. So be thinking about what you're finding. Ready for the next scenario? We have like a little bit of some theory. It's not real hard, but I'll kind of just mix it here. We have a little theory about something that's true about the dimensions of a triangle. It's not surprising that this is true, but maybe you're wondering what I'm going to do with it. So, of course, that's what the law of sines says is true about the sides and the angles. Actually, what we're going to do with it is we're going to notice that this would then insinuate that side B would equal, so we're going to solve this for B. Well, now that we mention it, we could say that side B, if I just multiply the sine of B up here, side B equals A sine B sine of A. Now, again, maybe you're saying, so what's up with that? You'll catch on, because what's up with that is we're going to play another replacement game. The replacement game is right here. You see, that's side B, and that's side B. But if I replace it, I end up with like a new formula. Okay, let me give you the formula, excuse me, let me give you the title of the formula, but then we'll do the fun part, which is to replace it. I like to call this the triple angle plus one side. This is like the triple angle formula. You'll kind of hear me say that as just a little catchphrase. So what's the triple angle formula? Okay, kind of follow the bouncing ball here. I can pick up where I left off with 1/2 AB sine C, but I can now replace the letter B. Now, when I replace the letter B, I'm going to get another A. I'm going to get another A. Now, I already have an A that was part of the formula, but if I get another A, then it ends up being A squared. Okay, that comes from this other A. I also end up with a whole bunch of signs. I also end up with a whole bunch of signs. Two of those signs, the sine of B over the sine of A, the numerator and denominator, came from my substitution. The sine of B over the sine of A. The sine of C, that's still tagging along from my original formula. So I end up with this monster. It's actually not too hard. It's just a triple angle. You have all three angles, and then you have a side. Now look at something with me. The angle and the side will always match up in this manner. So the angle will always be in the denominator, matching with the side squared, the side that we have.
So you multiply the sine B times sine C times sine C before you divide it?
Yeah, well, actually, that's just a good question about kind of the order of operations. The order of operations say that I can multiply and divide in any order I want. You might notice that it seemed like we were multiplying last, and then all of a sudden I kind of stuck it up here in the middle. You can multiply and divide numbers in any order you want. If you just do a simple multiplication problem, 4 times 3 divided by 2, I could do 4 times 3 divided by 2 any way I want and end up with 6. Do you see the other variations here? Okay, if my side that I had was side B, then, well, that would be the one that's squared. Now, what I like students to notice here, and you'll catch on, is that the angle that matches with side B will always go in the denominator, which means that the only thing left is to put A and C in the numerator. And maybe you want to fill it out that way also. Do you want to try to do the third one? How'd you fill it out, Brandon?
At A equals 1/2 C squared times sine A sine B over sine C.
Very good. 1/2 C squared sine A sine B over sine C. Now, sometimes at this point in the lesson, people are like, whoa, what's going on here? Work your way back through. What's going on here is we're finding 1/2 base times height, but we started to vary how we can describe the height. We varied it using some signs, and we decided to do another substitution, and then we end up with this formula. Okay, honestly, they're all the same. They're all the same because they're all from the same, well, parent formula. But of course, they are nice when you are given, in this case, a triple angle and one side. Here, try it. Well, I'll let you kind of notice. Here's a problem that can fit into this formula. So we got A equals 18.6. Angle A is 19. Angle B is 64. Now, if you're plugging this in correctly, you're getting an answer really darn close to 474. 474. One half 18.6 squared with a fraction then that says sine of 64, sine of 97, and divided by the sine of 19. You can type the whole thing in. Get to know your calculator and what you're comfortable with. Again, you actually can type this whole thing in. You don't have to break it down into 2 or 3 steps if you don't want to. What do you see? How does it vary from how you typed it in? Again, kind of like Brandon asked, and the answer is you can multiply and divide in any order you want. So I can divide at the end. I can multiply the rest of the numbers right on through. Don't forget to square 18.6. I guess if we're going to round to 2 decimals, then, as I said, you're really darn close to 474. 473.99. Questions? Are you sure? All right. Now, our next formula actually don't have a cool, hey, if you do this and you do this, you end up with this new formula. This is kind of one of those formulas that, honestly, a mathematician discovered. And if you're one of those lucky people that discover a formula, you usually get your name written after it. This is Hero's formula. Hero's formula. I didn't know the guy personally, but he came up with the side formula for the area of a triangle. I've also seen it spelled Heron with an N. I guess maybe he had 2 spellings, or he wasn't sure how to spell his name. Here's the side formula. It's kind of unique, okay? Right away, it's unique. It's got a square root, and then it's s minus a, s minus b, times s minus c. So it's it's the square root of s times s minus a, s minus b, s minus c. Now, not the hardest thing all year, but I still want you to be thinking about these letters. I mean, what do you think as you look at the letters in the formula? Thoughts on what they represent? How about A, B, and C? Thoughts on what they represent?
Given sideline.
Okay, so we kind of have those accounted for now. All right, A, B, and C are the given side lengths. S. Now, there's no reason you would know this, but make a good guess. What could you do with 3 given side lengths? And the letter S. What could you do with 3 given side lengths? Pardon? I suppose you could if there was a right angle, and I like that you're thinking of something that starts with an S.
Right.
Yeah. Now I'm going to add something to it. There's no reason you would know this. It's half the sum. It's called half the sum. So S is equal to half of the sum. Just kind of thinking a little bit. We've got 3 sides. You can sum them up. It's half the sum, though, and we call that the semi-perimeter. Now, the honest truth is the reason that we call it S is because of the word semi, but it still makes you think about it. It's half the perimeter. We call that the semi-perimeter. I don't have like a little proof or a little where did this come from. I like to be that kind of teacher for you, but I just don't have it. So we've got this formula. We're going to use it. It's kind of intriguing. It uses a square root. Okay, I kind of have a hunch that there might be something involved here with the Pythagorean theorem, but again, not exactly sure. So, but let's use the formula. As we did with the other problems, A equals 30. I'm going to give you 3 numbers here. So A equals 30, B equals 40, C equals 50. I wonder if you can set up this formula and find the area. Now, just to make sure you're getting off to the right start here, you should be finding S. Like the first thing you would really need to do is you would need to find 1/2 of the sum. Now, if you're a little bit of a speedy student this morning, you already have an answer, just kind of look at your triangle again, and I want you to see if you notice anything. So again, once you get your answer, just go back. Do you notice anything? Do you notice anything about how else you could have found the area? Again, how else could you have found the area? Just a little by the way here, your smart students, do what works for you. You can do that. You can do this, where, you kind of do some of the math beforehand. What do you want to type in your calculator? I would prefer to type that in, but whatever kind of works for you. I mean, you should show the setup of the problem, whatever you need to set up, and then obviously you're pushing some buttons and out pops 600. Make sure out pops 600. Does anybody have any questions with that? There's something special about this problem. And it's honestly to help us kind of notice something about all these problems. There's something kind of special about these numbers that is supposed to help us realize something. 3, 4, 5 is a right triangle. You might say this was just a right triangle in disguise, but no doubt it's got a base and a height. Could I have found the area using the base and the height? Well, sure, because ultimately all these formulas go back to that. Okay, so 1/2 of 1200 is also 600. But wait, could I have done this problem with side angle side? Could I have done it with side angle side? Well, yeah, because every triangle has a side, an angle, and a side. By the way, I could have used this angle if I wanted to. I would have had to find it. If I found it, would I have 3 angles and a side? Yeah, I would have to find this angle. Okay, my point is that in some way, every one of these formulas can fit into every triangle. Now you might say, well, why would I do that if I already have 3 sides? Well, yeah, okay, but you might do it if you, I need some space here. You might do it if you have this scenario. Good, we have some time here. I'm just going to put this underneath because I don't want to erase all these formulas, but what would you do if you had this scenario? Side A equals 10, side C equals 15, and angle A equals 33. So side A equals 10, side C equals 15, angle A equals 33. Now, if you're kind of saying, I don't get it, Ms. Naylor, it seems like you're trying to show us something new. What's new? I don't get it. Well, almost every problem we do, making a sketch is helpful. Particularly in this problem, you start to make a sketch, and I hope you realize a number of things. One of those things definitely being that these 3 dimensions do not fit into any of these categories. Are you tracking? The most common mistake is for kids to say that this is side angle side when you just look at the numbers, but I know you know that's not side angle side. It's actually side angle. Dum dum dum. Now, we don't have another formula. We don't need another formula. We just need to realize that any one of these formulas can fit into this problem. Okay? Dig into it a little bit. I kind of just want to let you look at this and think about, wait a minute, how could you fit it into one of these formulas? Okay, I'll say nicely that there's really only one thing that you can be doing right now, and it's not finding the area. Okay, you're not going to find the area first, but there is one thing that you can be doing. If you haven't seen it, or just to make sure that you're on the right track here, the only thing that you can be doing is solving for something, solving for angle C. Okay, so if you're doing that, good job, keep going. If you didn't do it, take a little look up here, because the law of sines to the rescue. The law of sines helps us to find something. Angle C comes out to 54.78. Angle B comes out to 92.22. Your final answer comes out really close to 75. How's that going? The area comes out really close to 75. Liam, how did you proceed after you found a couple angles here?
I just used triple angle on one side.
Which version did you use?
I did a squared.
All right, so we're going to use the a squared one, so it's going to look like 1/2
Squared.
10 squared, and then set up your fraction here. It's going to be the sine of
Sine of 54.78. Sine 92.22. Over sine.
So he used the triple angle, and in fact, you decided to use the A version, and that is definitely a yes. By the way, could we have used the triple angle and used the C version? Yes. Just kind of curious, anybody do it? Okay. But if you did it, you would find out that it comes out to be the same answer. It's going to be very close because of rounding. What else could you do? Did anybody use side angle side? Which side angle side did you use, Ryan?
AC.
Yeah, it's kind of the one that makes the most sense. So what's it look like? It would look like 1/2.
1/2 and
Yeah, again, each of these comes out really close to that number. I just kind of rounded to 75 when I gave the answer. Any heroes out there? Okay, usually not, but all you would have had to do is find side B. You could have found side B, extra step, but it would work. So, side angle, okay, we don't have a new formula. We just fit it into one of these. Okay, not a bad little lesson. Now we'll take this and we'll kind of expand it and mix it in with what you did on the test. Homework helper. You'll start to see these off and on throughout the year. A homework helper is really just, instead of the problems being in the textbook, they're on a PDF. They're on a PDF. I don't think you need to print it out. You probably just look at it on your computer or your phone, just like you'd look in a book, and you'll see some questions that will get you thinking about the lesson. Okay, so again, homework helpers on Classroom.